Good afternoon from Singapore and to all our friends tuning in from all around the world. Thank you and welcome to today's session of 5G, AI, and mobile networks of the future. My name is Wei Min from SGInnovate. We are a government-owned organization in Singapore who believes in the positive impact of deep tech to benefit humanity. A good part of our work also involves building a global community of scientists, commercializing research, building deep tech talents, as well as working with our ecosystem partners in scaling deep tech for improving the lives of many around the world. And that is why we have formed this community where our work in investing startups, corporate collaborations, and promoting knowledge sharing enable us to scale and build deep tech innovations for the world. Today, we have partnered with the International Telecommunication Union to present to you this webinar on 5G. I am sure that everyone here has been hearing so much about 5G in recent years, from how much faster it may improve your video streaming to the kind of technologies that 5G will be able to disrupt in areas such as autonomous systems and possibly even application users, such as doing surgeries remotely across the world. However, today we will be talking more about the applications of AI and machine learning, which could potentially help mobile operators to address some of the challenges in the adoption of 5G and also opportunities which could potentially drive new businesses and revenues. With no further ado, do allow me to pass the time to Dr. Chesed Lee, Director of the International Telecommunication Union Standardization Bureau, for the opening remarks before we start the discussion for the day. Dr. Chesed, please.
Yeah, thank you very much. Good afternoon to Singapore. Good morning in Europe. We are now a very fine day today. I would like to start with my thanks to SGInnovate for inviting me to speak at today's webinar, 5G, AI, and mobile networks of the future. It has always been a pleasure to visit Singapore in person, and I hope that sometime in the future, I will be able to visit Singapore again. I'm an engineer. I'm a network architect. So I always keep an eye on Singapore for the latest technological developments. Today, we will look for the future. Many people have different views about the timeline of the future, possibly 2025 or 2030, even further. ITU, as a UN special agency, our first goal of the future should be year 2030 with SDGs, Sustainable Development Goals. This is a very, very important objective for all UN agencies. In any case, whether we look year 2025, 2030, we should be considered what we learned from COVID-19 pandemic. To our observation, connected life just begun. We said connected the world several times. We frequently use of the language, but to our observation, real connected life just begun. So connectivity has become essential for everyone. So ICT, telecom infrastructure, is really essential infrastructure for everyone. But we realized connectivity itself is not enough. So ICT telecom equally available for everyone. In addition, this will make people safe and convenient. So AI will be the dominant technology of the future. In particular, we generally understand, bring smartness to the community and the people, so will impact every corner of society. In general, AI has been used for applications, in particular, analyze user behaviors and preferences, as well as something prospecting some sense of near future via big data analysis. Not many organizations try to use AI for networks and telecom. ITU believe AI and machine learning will have great contributions to shape how communication networks, a lifeline of our society, will be run. So every company in the networking business is now investigating the introduction of AI machine learning with a view to optimizing network operations, increasing energy efficiency, and curtailing the cost of operating network. However, applying machine learning to communication networks faces a different set of challenges than other cases of application. For example, machine learning for image recognition. Communication networks, it's difficult to say, very well designed to cope with the big data analytics and machine learning. So therefore, future networks need to be designed and operated to do so. To analyze the impact of machine learning on communication networks, which are bound by constraints on communication resources and operate in a noisy and very dynamic environment, are challenging tasks. We talk about data is everything, but the lack of unified data format and constraints on computing resources, bandwidth, latency, etc., make the use of machine learning challenging. This is in particular true for mobile networks like 5G. What data is available? Where is data generated? Is the data labeled? Can data be trusted? What is the quality of training data? How can the performance of machine learning systems be assessed during the operation? What are the privacy and security implication data formats and machine learning techniques? All those are questions. ITU has been at the forefront of exploring how to best apply AI machine learning in the future networks, including 5G networks. So we are studying the implication of machine learning on network architectures. We are developing a toolkit for the integration of machine learning into 5G and the future networks, comprising currently around a dozen of technical specifications. Standards will be important. Different parts of the network will be supplied by different vendors. ITU's toolkit helps different parties to look at the intelligence level of the network, helping operators to evaluate vendors and regulatory authorities to evaluate the network. However, ITU is not just developing the theoretical underpinning of machine learning in 5G networks. ITU is also examining whether the architectural framework we developed works in practice. So to this end, ITU has launched the ITU AI Machine Learning in 5G Challenge. Hundreds of professionals and students from prestigious companies and universities around the world are participating in the ITU challenge and are solving problems that 5G networks are facing. Here is one example of problem statement. How does the weather influence the radio signal to and from base station? So participants get weather data and network data and use AI machine learning algorithms to find patterns in order to make predictions that would help the engineers to fine-tune their networks. We have also a weekly ML5G webinar series, which gives students and the professional tips on how to tackle the problem statements. The challenge will last until the end of the year at the final online conference in December. The best teams will get awarded prizes. I invited companies and the universities of Singapore to participate in this challenge, as well as outside of this, all the world. The deadline to register this challenge is 31st of July, end of this month. So having said that, I thank you again for addressing you today, even in virtually. ITU is keen to work with Singapore and I look forward to the rest of the discussion. I wish you a very successful webinar. Thank you very much.
Thank you very much, Dr. Chasup from ITU, for your opening remarks and sharing about the important work that ITU is doing, whether on standards or even inviting participants globally to join in the development of standards and also to join their working groups. So good afternoon, everybody, and a very warm welcome. Whether you are in Singapore or watching from overseas, we're glad to have all of you here with us for our online panel discussion, 5G Network Management, AI and Mobile Networks of the Future. We'll begin with a quick round of introductions. Panelists, please share what you do briefly.
Hey everyone.
Yeah.
Should I go first?
Yes, go ahead.
Hi everyone. I'm Connie from Singtel. So I'm the Director of Strategy and Planning in Group Enterprise. At the same time, I'm also helming the Center Director role for our Singtel Future Now Innovation Center. So this is a state-of-art innovation center. It's a very key customer engagement point where we showcase our in-flight as well as advanced technologies across the whole of Singtel Group. And we use the space to also inspire our customers and key partners to basically ideate and to co-create technology solutions with us. So that is a very key innovation point, that we have within Singtel. Yeah, that's it from me.
Thank you, Connie. Henning, would you like
maybe
to go
I can continue. So my name is Henning Zanek. I'm with Nokia Bell Labs in the Standardization Research Lab in Munich, Germany. There I'm leading a line team on network automation, and our current work areas are basically 5G RAN management, self-organizing networks, also extended to the edge cloud, cognitive autonomous networks, so meaning we want to go from rule-based to learning function, which is actually also the topic today. So we have a pretty long history in analytics work, which we extended then to machine learning. And now we're also looking, of course, into architecture interfaces, meaning bringing this to the 3GPP at CSM landscape, but also looking at the framework given here by the focus group on ML5G. We also work on network slicing management, and we're trying to do all of this across, say, communication service provider scenarios and also campus networks. Yeah, thanks.
Thanks, Henning. And over to you, Vishnu.
Hi, my name is Vishnu. I work in the industry, especially telecom industry, developing standards, implementing hands-on for about 2 decades. After that, I moved into front-end standards work that involves work with focus group, ITUT focus group, and other standards bodies and open source. Last 2 years of work, which I would mostly focus on today, derive upon my work for today, is for ITUT focus group machine learning in 5G, which Chasup just now mentioned. I also work with other industry bodies, coordinating between the liaison between ITU and other industry bodies, open source, academia, especially for student projects for ITU. I also coordinate the ITU AI ML in 5G challenge that Chasup just now mentioned. Thank you.
Thank you, panelists. And I'm Annabelle. I lead the development team at SGInnovate. I work with our founders to help them grow their companies. And I also work with corporate leaders like the ones that you see on this panel today on helping to bridge them to startups and introduce them to startups. So I'm very excited about the panel discussion that we have today. I will first ask a few opening questions and leave lots of time for the audience to participate. To ask a question, simply type it using the Q&A function on Zoom and we'll get to them. So to kick us off, 5G is the next generation mobile network that promises to be a game changer when it comes to how we live our lives. So panelists, what are you most excited about with the advent of 5G?
So maybe I'll get started first. Singtel has just been awarded a license to actually operate and to deploy the 5G networks in Singapore. So we're definitely very excited. We see 5G as the next generation of communications technology. And 5G with its high bandwidth, super low latency, greater throughput, faster speed, that is really going to enable massive connectivity. right? It's going to support, the transmission of large volume, large velocity of data. We see that as a game changer for digital transformation. It's going to bring about lots of innovation as well, basically changing the way we live, work, and play. And we see that this network evolution will bring about, a business revolution of sort as well. It's going to change the way we think and run our businesses. It's going to help businesses pivot their business models, reinvent their business models, and it's going to bring about lots of productivity gains supported by 5G digitalization, not just on the enterprises, but even on consumers as well, right? We believe that in the consumer space, 5G will usher in a whole new generation of entertainment, so enabling technologies like AR and VR, that is going to give us widespread, super immersive, very real, immersive experiences, and we believe that, cloud gaming enabled by 5G will also liberalize the gaming industry, allowing high-end gaming to be accessible via all kinds of devices, so we definitely are very excited about 5G. We see that 5G will be able, to have the ability to unleash a digital future for Singapore, and it's really going to accelerate digital transformation for the whole of Singapore. Yeah.
Thank you, Connie, for the just sharing about some of the possibilities. Henning and Vishnu, would you also have something that you're excited about?
So if I can add to that, I completely share the excitement. Also, in my work with ITUT, what we also look at 5G in the sense of a playground. There is a playground built where you can come and build things, new services, enable new frameworks using open standard interfaces. Let me tell you the brief story about the two students in Nigeria. Two of our students who work with the ITUT focus group. They started from scratch, building these services for education content access, for schools, for youngsters, to provide education content, interesting content for youngsters over 5G network, over the network, using AI and ML to choose interesting content based on football or other games or other celebrities to reach to the youngsters. This is the kind of opportunity that we have. Once again, we look at it in terms of not only entertainment purposes, but also provide an opportunity, provide a playground to leapfrog from certain markets to address the sustainable development goals that Jessup told a few minutes back. Thank you.
Yeah, and also from my side, maybe let me add to that. I mean, on one hand, you could say, okay, right, yet another generation, it's just, again, more and cheaper bits, but I also, like Connie, believe, I mean, there are really new applications out there, AR, VR, cloud gaming, so applications where today still you're bound to some, say, local computing infra, some fixed line, right? And I mean, if you look, for example, also now COVID-19, this has really shown, that connectivity infra already helps a lot, yeah. And with 5G, again, you have more freedom, right? So to move, but then in current times to keep the distance, right? And of course, but also I like to extend it, let's say, beyond this, say, typical usual mobile broadband use cases. So there are many use cases, for example, let's take the industry, right? So they're very much wired still in terms of the infrastructure, right? So even if you just reconfigure a machine, you need to move a machine, you need to reconfigure the network, right? And there, I think, 5G has really potential to become this, say, unified communication fabric, yeah, because you cannot solve the use case with, let's say, industrial Wi-Fi just and fixed networks. Yeah.
Thank you all of you for sharing the excitement for 5G. And let's jump into AI and 5G, which is also today's topic. What are the possible applications of AI in 5G?
I think everything gets smarter when AI and 5G are combined. So AI can definitely make 5G networks better and smarter, by enabling the networks to do things like threat detection, consumption prediction, user trend analysis, demand forecast, as well as network performance analysis and prediction, right? So basically AI can allow the network to be self-healing, meaning that the network will be smart enough to actually carry out its own root cause analysis and patch its own problems before any anticipated outage happens. Right? And even if an outage were to happen, AI will be able to help the network self-heal and resolve some of these issues within a much shorter period of time. So we're talking about, a fully automated 24/7 monitoring of the network. And this ensures that the quality of service of the network goes up as well, right? And then on 5G enabling AI, definitely 5G will make AI perform even better. It's able to allow more complex AI models to run closer to the data source, enabling better performance of the applications. It's going to power up, edge compute capabilities and all. And because 5G, because of its high-speed connectivity and super low latency, is going to enable the transmission of large volume, large velocity of data, enabling what we call real-time analysis of data. And if you think about it, this is very important for your mission-critical applications. So you think about your drone operations, even your physical security, surveillance, or even remote surgery. So I think AI and 5G, lots of synergies between them, definitely.
Yeah, maybe I can add to this. Of course, I really concur with Connie here, but also a bit giving it maybe a bit more technical angle here. Yeah. I mean, what comes first, what comes second? So first, I think we will always see this management plane thing. So right, we already see, of course, in 4G already, anomaly detection, load balancing, prediction, energy saving. Then I think second is really bringing this closer to the user and control plane, which I think also this focus group on ML5G is looked into, beam pattern optimization, massive MIMO scheduler things, also energy saving again, net level. And then I think what I like particularly, I think is the most promising thing is that actually AI in 5G allows us to connect really this, say, application domain data with the telco domain, for example, again, taking this non-public networks industry 4.0 scenario, right? So there we can, for example, take data, mobility data from AGVs and correlate this really with the conditions of the radio network in the factory, and we have access to all of this data. So I think this is a great promise we can and then really also learn from one deployment scenario to another, which we already do for communication service provider scenarios, but also for these other scenarios. So I think that shows great promise.
So if I can add a brief point, at the focus group machine learning ITU, we did a lot of paperwork. I mean, about a year back, we started studying the use cases, exactly like what Henning just now mentioned: energy saving, resource management, security related, how to make the networks more safer, traffic classification, how can you get more priority for certain types of traffic and so on, load balancing, Henning already mentioned, caching, how can you cache intelligently. This kind of studies we did, we really classified the use cases. We looked at which kind of data, which kind of models. We really split the hair, so to speak. But then at the end of the year, we put all this nice report. We published it actually. ITU has already published it as supplement 55. I can give the link. The problem is that we realized at the end of it, the use cases are already outliving us, so to speak. So the use cases continue to evolve. So our aim while analyzing these use cases should be also to handle future use cases. How can you make frameworks which actually could handle future use cases? This is one of the challenges which has this analysis of use cases has taught us. Thank you.
Thank you. And I think as we're also talking about use cases, I think one of the questions is how have you seen success stories or positive use cases of AI and ML in mobile networks today?
Yeah, maybe I can start also a bit with this vendor perspective. So, I mean, a few years back, for example, we started on anomaly detection, particularly with regard to cell anomaly detection, right? And there, at that time, people, were very tied to thinking, okay, an operator always needs to set everything in rules, right? And these rules needs to obey it. And so we really had to convince people, but this is now all over the place, basically, right? So in our software business unit, in the services, you know, everywhere you have this type of anomaly detection where you just throw in an algorithm, basically. The algorithm tunes in basically to the right operating point. You don't need to set any specific cell thresholds for rural and urban, whatever, right? So it's really working well. We also have now, for example, self-organizing networks, something we call cognitive self-organizing networks. So that means in the past, we moved basically from this manual configuration, you know, to script-based configuration into real functions which do this based on their rules, yeah. And still those functions had to be adapted to the deployment context, yeah. And now we have, for example, even the product, we have a mobility load balancing algorithm, which actually can over time really adapt to the specific context. You know, for example, if you see high speed users versus low speed users and so on, things which have been difficult really for this rule-based things we can do now, which still much less, say, human supervision in the actual deployment. Yeah.
Yeah, if I can add to that, it's too early to talk about success stories of AI/ML. We are in that journey. We are currently in that journey. However, we are experimenting with it, which is really exciting. Like Connie told us earlier. There are certain aspects which I would like to touch upon, which in the context of the AI challenge that Chesab talked about in the first talk, the AI challenge has thrown up several problem statements. So many of them in several layers of 5G. So for example, beam selection. Beam selection for massive MIMO is an important problem for all operators. And that has been, is being studied in the context of this AI challenge by, you know, what should I say, crowdsourced model of several 100 participants across the world. Similarly, for capacity improvement, performance studies, compression, overhead reduction of integrating AI/ML models in the networks, channel estimation problems, you know, and smart transportation problems, or automated cars and how do you do it, and entertainment shared experience, AR, VR, using AI. These are all under problem statements under study. We could discuss more, and I could provide the links, which are, of course, openly available, and we are very happy to discuss more. Thank you.
Yeah. I just want to add to what Vishnu said. You know, I think we're really on this journey. There are many examples of network vendors as well as operators across the globe, you know, on how they are infusing, interweaving AI into their networks, you know, to bring about self-learning, self-healing, and even self-managed networks. So I think we're on a journey. I think eventually we'll get there to a completely self-managed network. Very exciting future ahead.
Thank you. And while we are on the topic of also use cases, there's this question that came up from one of the audience asking what are some of the new use cases in private, public, and the non-profit spheres that can be empowered by 5G in Singapore, and why can't we do these now? So maybe we can take the first part of the question first, as what are some of the new use cases that all three or any one of you see in the private, public, or non-profit spheres? Not necessarily in Singapore, but also if in Singapore, that's also fine.
Okay. I talk about some of the use cases, right, in the enterprise space, you know, Industry 4.0, smarter manufacturing, you know, the use of digital twin, IoT, massive use of big data, robotics and all, you know, that will be really impacting manufacturing and enterprises, you know, in the private space. We also see 5G uplifting the entire of Singapore, not just for businesses, not just for consumers, but also in the smart city space. Singapore is big, you know, we're huge into smart nation initiatives, right? And Singtel definitely see the application of 5G as a key game changer for many of our smart nation initiatives, cutting across various verticals. So if you think about it, you know, airport, seaport, smart air and seaport, leveraging 5G to bring about, you know, state-of-art technologies. For example, your smart seaport, you know, this whole remote control of cranes, remote control of AGVs, you know, better automation and stuff like that. In the area of public safety, for example, with 5G, now we can have real-time surveillance. And then, for example, in the area of urban mobility and transport, right? This can be a private play, this can be a public play, but 5G definitely comes on board to enable things like your connected buses with real-time video surveillance, dynamic traffic light control, fleet management of autonomous vehicles. So I think 5G is really going to propel, this whole AV industry. Your V2V comms, your V2X comms, this is where 5G comes in here with the super low latency to enable that real-time, instant feedback. And of course, in the verticals of healthcare and education, right? I think one of the panelists talked about using VR and AR for training purpose for education. And this is going to bring about this whole phenomenon called the Internet of Skills, where now skills and competencies can be transferred across space, across the internet, basically, changing the way we learn, democratizing labor at a global scale, right? And in the healthcare industry, I think someone talked about remote surgery just now. Telemedicine will be better enabled by 5G. And then, of course, you have your remote medical training. Yeah, so lots of use cases in various verticals.
Thank you for sharing. Maybe I'll also pose a more difficult question. What for Henning and Vishnu, what are some of the more viable use cases? I think one of the questions was specifically for the financial services sector, but if you can also maybe share another viable use case which you think, and also why some of the use cases we can't do them now. So how do you distinguish between just a test bed or just a use case which might not be commercially viable versus a use case that is viable or commercially viable?
So I can go from a standards perspective. So what we did is to analyze exactly this problem. What stops us, and what can be done next step in terms of implementing the standards that we have produced so far, specifications that we have produced so far. I think the important thing is to go back to the pillars of the smart nation that Singapore is trying to do. The three pillars, if you see, is digital economy, digital government, and digital society. These are the three pillars. You can go back to that smart nation initiative from Singapore itself. And this is very common. I mean, this is not only for Singapore. I think the digitization of industries is a very important concept that has been built up. Digital governing is an important concept also. And another part is adoption and inclusion. This is where we come in. The innovation test beds that we build has to be interconnected using standard technologies. It should be interoperable. The technologies and tools and software and hardware that we put in the test beds for integrating AI ML in networks has to be interoperable. It should be, data should be collaboratively built into such test beds, and contribution on the global table in global standards has to be enhanced. And if you see, these are all, what I'm saying is not new. It's all part of national AI strategy of Singapore itself and many other countries. Collaboration is the key. I think the part to answer the second part of the question, why can't we do this now, is because we need to have more participation in standards, interoperability, interconnected test beds. This is what ITU is trying to do. Thank you.
Yeah, I think first of all, anyway, you hit a very interesting question there, right? So I think we can do actually, when you look at the lab, right, in isolated settings, we can actually do much more than what are the common use cases accepted today. But then I think it's a lot about automation, right? That you can do, let's say, very, very challenging use case at any place, anywhere in the network, basically, right? And that really requires, let's say, specific adaptation. Maybe one concrete example, I mean, anyway, the industry use cases Connie raised resonated a lot. Yeah, I think it's also, for example, healthcare, this emergency assistance. Yeah, and there you have sometimes really extremely tough use cases like, for example, remote stroke assistance. That means you need actually somebody who remotely can monitor in very high resolution certain imagery, but at the same time can really control the medication to the patient, right? Yeah. So that's extremely challenging in terms of the frequency of actions, right? But also in terms of even this uplink bandwidth, right? And I would say we can do this today with a deployed 5G network to some extent, right? But to do this, you really need some adaptation in the network, right? And that we only can do with automation, which in turn needs really this AI support that you can detect the situation and then really focus on the important use case. Yeah.
Thank you all for your responses. I think I wanted to delve deeper also on what Vishnu mentioned on standards. So we have a question coming in from Ashish about what are the cybersecurity standards and algorithms for 5G infrastructure, especially to secure the network for strategic applications like IoT and healthcare. So this is actually one of the several questions on security in this, and I wanted to hear the panelists' thoughts about security and also standards for 5G.
So I can pick up certain specific aspects of it, what we have worked upon so far. So in the focus group, we studied these kind of use cases. If you look at the specification supplement from ITU, it talks about use cases. Security is a specific section on it, which analyzes these use cases. We have looked at requirements specific to security related use cases. And another thing which we did also is to look at privacy preserving mechanisms and data handling mechanisms, which can enable AI ML in the networks, but at the same time preserving the privacy and security of the data which we are using for this analytics purposes. Once again, in the context of the challenge, there is a specific problem statement which again is very popular, and it deals with exactly this, to build a framework for privacy preserving mechanisms over networks to exploit the data, but using secure mechanisms for integrating AI ML mechanisms in the networks. This is and if you look at the ITU specifications, we also looked at data handling mechanisms, which has built-in strategies and requirements already built in at design time itself for secure mechanisms for using data while for AI ML integration in the networks. Thank you.
So can I just share that Singtel, we're actually building a very robust 5G architecture, and that consists of a very strong cybersecurity framework. Cybersecurity is really big, in all our digital solutions. We always ensure that whatever solutions we roll out are secure by design, right? So underlying our 5G architecture, we have got very strong, network security design principles. We do defense in depth, we do zero trust, network element assurance, and various, cybersecurity features, injected into the framework. Yeah, so, if we see 5G propelling IoT, bring about that massive explosion of connected devices and all, that is going to give us a huge pool of data. So the key question is really this: how do we manage and protect this pool of data, right? So I think cybersecurity is definitely very much intertwined into this whole new generation of communications network.
Yeah, maybe I can just add, because the question is specifically about 5G. I mean, 3GPP, right, has a very systematic approach, meaning that requirements, for example, from IoT and healthcare, they come in via the 3GPP SA1 working group, and then other working groups, in this case SA3, for security, is actually taking them up and trying to, of course, align also, with other groups, of course, security, and manage on a really cross concerns, and of course also often constitutes, let's say, trade-offs with other interests. Yeah, and I think in 3GPP particularly, we see that it's pretty well balanced between the working groups. Yeah, that these security requirements are taken into account, and then also linking to the AI topic. Yeah, of course, data collection currently for 3GPP data collection. Really making even this data accessible via standardized interfaces is really important. Of course, they also look very much at that this control points where you access the data, that they are secured. Yeah.
And also, since I think, thank you for your responses again on that. And I think we hear a bit about security by design, and even some of the working groups that are, especially the work of ITU, coming together for helping to set up standards for security. I think one of I see another interesting question here is that again, is also still on the topic of security, where we have a question from King Hui from I2R and from A-Star, where he said that self-healing network sounds like a really good idea. However, with experience from self-learning chatbots, what kind of safeguards can we put in place to prevent networks from being controlled by malicious actors? And I also like to combine it again with how is AI applicable for 5G network security? So if you can give specific examples of maybe about self-healing networks, also how you use AI for 5G network security.
Of course, then maybe if I may start, of course, then it's also kind of the battle, right? So AI is used by attackers and AI is used to identify attackers, right? So, I mean, okay, first of all, I mean, also particularly because the question is about self-healing, right? So first of all, you need to take into account that basically in the network, to be self-healing, it takes in, if we look now at CSP scenarios, data from many different terminals, right? So meaning, as an attacker, you have to, bring like a bot network, right? You have to bring very many devices under your control and then act in a comprehensive way, right? So that means the entry barrier, maybe compared also to other attacks, is actually quite high, right? But then on the other hand, of course, it can lead to that, inject measurements and then the network takes certain decisions it wouldn't have taken without the same malicious data, basically, right? But again, on the other hand, of course, and that's the beauty of AI, of course, you have all of this history on data. The network can really tune itself to even better understand, okay, what is the normal situation? And then what is really the abnormal? Abnormal meaning, really some trouble caused, for example, by a human misconfiguration or some trouble caused by an attack, basically. Yeah? So this is in the way inherent that you try to detect then this abnormal situation and either categorize it as this, kind of operational problem or a security problem, basically. Yeah?
So if I can add to that, there are two specific mechanisms that we built in ITU specifications to address exactly this problem. One is to build in operator control. That is through policy mechanisms. So the network doesn't run away by itself, but even though it is autonomous, but it is controlled within the limits of the contours of the policy, which is set by the operator. So this is one aspect. Yes, it is self-managed, it is self-healing. It is able to adapt to situations, but within the contours of the policies which are set by regulatory bodies and operators. That's the first part. Second part is, like Henning just now mentioned, you are able to evolve within the networks. You are able to adapt within the network, but for that you need to test and verify what the model is going to do. How do you introduce a model to the network and let it do whatever it wants? That's not possible. So you need a sandbox mechanism which is integrated through standard mechanisms and interfaces and technologies, which we are able to test these models before and verify these models possibly using real network data before we inject such models and its output onto the network. This is what we call as a sandbox mechanism. These two are specifically built in to address at the same time autonomous, but within the contours of security. Thank you.
Can I also add that one of the inherent capabilities of 5G is network slicing. So because of the high amount of bandwidth and spectrum, we're actually able to do network slicing. So what exactly is network slicing, right? A network slice is basically an isolated end-to-end piece of network that has been tailored to meet specific requirements of a particular application, ensuring maximum quality of network performance, right? But inherent to that, it gives us the ability to actually isolate network groups. So if one is down, the rest is not down. Yeah, so I think that helps to actually increase the resiliency and the security of the 5G networks as well.
Thank you. And I think Connie brought up a good point on network slicing. I think one of the things that we think about is also what's the business model that would emerge with the investment, huge capital investment in 5G, and how we can make that viable in the longer term. So one of the ways, of course, is using AI and doing network slicing. So we'd like to hear from the panelists. What are the business models that you would think would make the investment in 5G viable using AI in the longer term?
I would just go ahead, Henning.
I just wanted to pick up on the network slicing because it's a very, I mean, first of all, of course, it's a technical feature you can use for all kinds of use cases, like, for example, isolation, security, but also really to run simply different services and treat different users, UE populations differently, right? But I think it's really, you can actually address all of these customer segments between, say, the end users on one hand and this big enterprises, you know, the operators have anyway done special provisioning, special projects for, right? So it means all of this small enterprises, medium enterprises, you can actually enable to run really, let's say, their own service and offer this basically. Yeah. So I think this will be a big difference, yeah, to this pretty fixed, you know, end users focused and big enterprise focused business models of the past. Yeah.
I completely agree with Henning. In fact, I was just going to say that expanding upon what Connie told about network slicing, it is very important to look at what is the value which is provided by network operators and the ecosystem in general by integrating AI/ML. Before looking at business models, let's look at the value which is provided. How can we exploit the data for a better sustainable development goals and business together? Just take the example of what happened very recently, right? Contact tracing. Contact tracing required data from operators, but at the same time, external data as well. You need collaboration, you need standard interfaces to put two and two together to do contact tracing and defeat a particular pandemic, right? This is a very good example where we could provide combined value. Another part is that in ITU, we also looked at what is called as marketplace. Marketplace is where vendors, ecosystem providers, academics could come with machine learning models, AI models, and get it trained in a standard interface, using standard interfaces in network operators sandbox. So it is built upon the toolkits that Chesa mentioned in his talk. So you have a toolkit where you bring in AI/ML into 5G, use researchers, academics, and industry players could bring in, train using the data, and provide a marketplace so that you derive value out of it, and business will follow. Business will follow where value is. Thank you.
Yeah. I think I agree very much with both Henning and Vishnu. Singtel, we are building our business model. Is confidential, so I can't share much details. I believe that many other telcos, you know, are in the process of actually working out and refining the business model. But I think what I would like to say is this, right? The entire 5G roadmap has to be one that is very use case driven. Like what Henning and Vishnu has shared, is very much enterprise centric as well. So what Singtel is doing right now is to build an entire ecosystem of 5G partners. So we're getting various partners on board, our enterprise customers, to basically think alongside with them how we can leverage 5G to help them solve their business problems, to help them solve their business challenges. So I think this is really the way forward. You know, we have set up, you know, 5G Garage, you know, where we invite our enterprise customers to actually carry out use case trials alongside with us, free of charge. You know, so we work with them to develop the use case, you know, and then from there we will work out the business model. Yeah, so I agree that the investment is hefty. It really has to be enterprise and use case centric, this whole roadmap.
So I have one question from the audience from WW. He asks, or he or she asks, will the upgrade to 5G consist more of hardware or software upgrades?
I think it's both, right? So you need your 5G headsets, your 5G phones, your 5G chipsets as well. Yeah, so I think it's a combination. Maybe Henning and Vishnu, you may want to.
Yeah, exactly. I mean, on one hand, of course, it has been designed very much to be integrated with 4G, right? So then basically you can start with software upgrades and then basically non-standalone mode, yeah. But in the end, of course, when you then also go really to the higher frequencies, right, to millimeter wave, again, then it's of course also about new hardware, new antennas and so on, yeah. But this is, of course, are then also, yeah, simply covering, let's say, different use case scenarios, yeah.
Yeah, I completely agree. I think that there is a lot of open innovation. If somebody is interested, they can look at what is happening, experiment with things. I wouldn't call it software or hardware. I would call it platform. I mean, you could have a mix of Lego pieces, which could be software based, cloud native, virtualized. You know, whatever you want. The 5G allows us the flexibility to mix together and build solutions. Using such virtualized and cloud native platforms. That is the flexibility, that is the advantage which we get. Thank you.
Okay, and I think what Henning also mentioned was, I think, using some of the 4G infrastructure. So I think while we are still beginning the early adoption of 5G, we still have all the 4G infrastructure going on. So what will the transition period look like in the next couple of years? And also what will drive the adoption of 5G?
Yeah, so I think many would have heard in the news for Singapore, by the end of 2022, half the city-state will have 5G coverage. And we're working towards the end of 2025 for the whole island state, right, to have the 5G coverage. So I think over the next few years, 4G and 5G will coexist. You know, and the infrastructure for 4G will still be relevant for 5G, except that 5G, because the wavelength is shorter, the range is more limited, we need to build more base stations. You know, so Singtel is working very hard with the various government agencies to plan for, you know, the building of the various base stations. So just to share an example, for HDB flats, you know, we install the antenna on the rooftop of the flat. There is this guideline currently that the antenna has to be mounted 3.6 meters from the edge of the rooftop. But because of 5G shorter wavelength, that guideline will have to be changed, right? So we're working with various government agencies like URA, HDB, MND and all to decide how can we, you know, mount the antenna. Can it be, you know, a shorter distance away from the edge of the rooftop? So there are all these infrastructure issues that currently we are discussing, you know, with the various agencies. Yeah.
Yes, just to pick up upon that coexistence part that Connie mentioned, while they coexist, there is also this problem of in managing interference, managing the interfaces between them in a standard fashion. That is exactly where we have to look at, while providing intelligent services. It's not only for 5G, but also it is able to support previous networks also like 4G. This is where we need standards. This is what ITU does right now. And the ability to provide the backward compatibility, at the same time coexistence, using models and data to provide intelligent services is one of the aspects of ITU machine learning sandbox also, while considering 4G and 5G and unlicensed technologies coexisting. Thank you.
I mean, basically, as we speak, of course, there's already a lot of transition happening, right, with operators all across the world, of course, always a bit different per region, right? But again, also coming back to the use case we earlier discussed, of course, there's also a lot happening already in the industry sector, right? For example, in Germany, you can apply now for 3.7, 3.8 gigahertz license, right? So for campus networks, right? And then basically build in part or entirely your own network, right? For big industry players, for example. And that's also pretty exciting, right? Because then we have also in a way a complementary infrastructure, and some industry players, they really can satisfy the specific needs. And then, for example, with network slicing, again, also get this wide area service from the operators and so on. So that's pretty interesting new scenarios there, basically. Yeah.
Thank you. And we have a question from the audience from Ella, whether the panelists can talk a bit more about 5G versus Wi-Fi 6.
Yeah, okay, I guess we cannot get in every detail there, but I would say, like I mentioned initially, for example, again, taking this industry scenarios, right? So we are talking to a lot of different customers also in that space, yeah, and some, of course, are happy with the industrial Wi-Fi they have currently, or then also with advanced Wi-Fi 6, but others, they say, okay, they want really this, say, more reliable infrastructure, which can scale, you know, with the number of devices, you know, in a factory, for example, you have a lorry coming and then unloading, you know, sensor sensor devices, and then you have suddenly huge traffic, right? So dealing with this, say, exceptional traffic scenarios, dealing with also quite a lot of mobility you have in these scenarios. That's what they see and what we see 5G is will be really used for then in the end.
Yeah. I think there will be a very strong symbiotic relationship between 5G and Wi-Fi 6. And I think within the interior of a building, Wi-Fi will still be, much used, and much in demand. Yeah, but the good thing about 5G is if you think about a smart factory, right? With 5G, you don't need the factory to be dependent on your APs, on your access points. So when we talk about digital twin, cloud robotics and all, 5G will lend greater autonomy and flexibility to the layout of a factory. Or even with a retail mall owner, right? Singtel is in conversations with various retail store owners, and they're asking us, what is the difference? Can I just use Wi-Fi? Why do I need 5G? Then again, some of these owners, they want to install lots of smart devices and sensors, right? Across multiple stories as well. And this is where the APs come into play. With 5G, there's more flexibility. You don't need to depend, on your Wi-Fi APs.
I think I agree with that. It is not a question of either or. It is a question of identifying the correct deployment scenario. Some of our partners, in fact, research partners, academics, what they're trying to do in their labs, test labs, is to study exactly this problem. There is a deploy Wi-Fi unlicensed, licensed technologies under which context, which is better in which use case scenario. That is the question that we need to address. It is not a question of, picking one over the other. It's a question of picking one over the other for which use case. That is the question that which is being studied. And here again, what we worked on is our orchestration mechanism. So once you have these two solutions, how can you orchestrate intelligently the question of deploying these pieces, Wi-Fi or licensed technologies in a campus, like Henning mentioned, in a campus or in a wide area network? How can you intelligently orchestrate these pieces together to build an end-to-end solution? That is the real problem that we should be addressing. And that is where ITU has done some work in standardizing the interfaces required for orchestrating these pieces. That's, in my opinion, the correct problem to. Thank you.
Thank you. And I'm also just conscious of the time that we have. How does this discussion, so we also want to be more future looking, how does this discussion extend beyond 5G and even to future networks like 6G?
Yeah, maybe I can start by saying, right, so currently also in terms of the AI automation use case, we see this mainly in this management space, right? So network optimization, anomaly detection. And then for 6G, we will see much more of AI really also deeply embedded into the network, right? So there are pretty radical concepts out there, like, really like a self-learning receiver, right? So basically we really complement, let's say the traditional rule-based, let's say, receiver design and with or transceiver design with really deep learning basically embedded in the radio. Yeah.
I think countries like China and Korea, they have already started work on 6G. In fact, I heard talk that 6G will embark in the year 2027 or 2028, right? But I think the larger part of the world is looking at really how 5G will pan out, and whether telcos are also able to recoup, the investment that we have made in a reasonable manner. So I would say that 6G is still out there in the horizon. It's not going to take place so immediately. We'll give it some time. Let's see how 5G plays out first.
I think that I agree. It's not a question of 6G. It's a question of how do we evolve future networks in general? How do you lower the barrier for innovation? So you can adopt AI ML, you can adopt newer technologies, beamforming and beam selection, intelligent beam selection, and such kind of technologies, and also in the core networks similarly. lower the barriers for innovation in the networks using open technologies and standardized mechanisms, and shared data, like Chesap mentioned, shared open data which can enable intelligent services in the networks. Then automatically, it will become autonomous, it will become self-healing and all that, and then we will have progression towards future networks, or 6G, or beyond 5G, or whatever we call it. The important point is lower the barrier for open innovation. That's what we should be doing with neutral models, enabling sandbox, playgrounds, where the partners can come in and build their solutions using 5G networks, and automatically the underlying network will evolve. That will happen. We have seen it happen. Thank you.
Thank you, Vishnu, and thank you, panelists. So we're actually out of time, so I would like to thank all our three distinguished panelists, Henning, Connie, and Vishnu, for your time, energy, and your insights, and also SGInnovate as well as ITU for organizing this session. And last but not least, all of you in the audience for participating and engaging in conversation. So as you've heard, a lot of things, a lot of use cases, a lot more discussion to be done for AI and 5G, and also for the adoption, the deployment of 5G. So we hope that everyone here can continue participating, whether in the ITU challenges, challenge statements, which I think Vishnu has shared the link, or in some way or another as an early adopter or as a consumer of 5G networks. So thank you very much, everyone, for being part of this conversation, and wishing you a pleasant evening ahead.
Thank you, everyone. Thanks.
Yeah, thank you, everyone. See you guys.
Thanks.
Yeah, so thank you, Annabelle, for the wonderful discussion with the speakers. It's great to see that we actually have more than 100 attendees to attend this webinar. So we do have quite a number of questions that came in, but regrettably, we're not able to address all of them. But I think our speakers have managed to cover quite a bit of ground today with this session. So that being said, I know Annabelle has already said it, but I would still like to represent SGInnovate to thank all the attendees who have stayed with us till now. Also, a big thank you to our speakers, Connie, Henning, and Vishnu, and also Dr. Chesap for this webinar. For this webinar could not have happened without the great insights and discussion points that have been shared with everyone. So once again, to the attendees, do keep a lookout for our post-event mailer, which will contain a recording of the session, and do reach out to us at events@sginnovate.com. If you'd like to connect with our speakers or just to have a chat with us for collaboration opportunities, do drop us a mail. Also, do remember to give us your post-event feedback when you exit the webinar or through the post-event mailer as well. So, yep, this is Wei Min, signing out from this webinar. Hope everyone will have a great day ahead. Stay safe, stay healthy. Hope to see you again in our next webinar. Thank you and goodbye.
Thank you.
Thank you. Bye-bye.
Thanks.
Bye-bye.